Hello everybody, Mr. Rubo here, and today we're going to talk about solving polynomials graphically, and specifically we're going to be using our calculator a lot today. So first, with these problems, you'll actually see a lot more word problems with these, but we'll start with just be given an equation and asked to solve. So let's say we have 8 equals x cubed plus 8x squared minus 9x minus 64. So if it's not equal to 0 or like equals f of x or whatever, there's something over here. You do want to move everything to one side before we put it in the calculator. So I'm going to go ahead and subtract 8 by both sides. 64 minus 8, negative 64 minus 8 is minus 72. So at this point, once we have it equal to 0, and we're trying to solve, that's not how you spell solve. So you're trying to solve this polynomial, which means you're trying to find the x-intercepts if you want to talk about it graphically. Okay, so solve means find x-intercepts. Okay, so now we can go to our calculator. So let me just pull that up and pow, right there. So I did a little prep work, and hey, I put the equation into our y equals. Okay. So now, because we're just trying to find the y-intercepts, you can hit graph and you can see that one, we should at most have 3 zeros that we can see, 3 x-intercepts, and we can see them here. But just for sake of seeing, the really important things of the graph, so right now we're missing the top part and we're missing the bottom here. So that's where we can go to Window and change our y min and our y max to larger numbers. Now, I played around with it earlier, and it works out that you see it good. The graph looks very good if you change these to negative 100 and 100. So you want to keep your x min and x max at 10 and negative 10, but y min and y max should be negative 100 and 100. So now when we hit graph, hey, we can nicely see that local maximum and that local minimum. Okay, but we actually don't need those for the solving part. We actually just needed the x-intercepts. Now, you might be able to count on the tick marks, but you aren't necessarily sure that those are the correct, or like it's exactly on the tick mark. So, calculator is a really nice function, and its second trace, which if you look above, it does say calculate, and it brings us to this menu. This menu is super great when it comes to finding stuff on our graph. Value, it will tell us any specific x value we want. So if you want to say like x equals 2, it'll tell you the y value that corresponds to it. 2 is the 0, which is what we're going to do today. So the x-intercept. We will also look at doing minimums and maximums as well. Intersect is if you have multiple graphs and you want to find where they intersect. And then dy over dx and the integral of f of x dx. Those are two calculus things. We won't see those in this class. So today, let's look at 0 first. So when you hit 0, you're going to get this command that says left bound. So you want to look for your cursor, so you can see mine right there in the calculator, and you want to go onto the left side of whichever 0 you want to find first. So personally, I like to go left to right, so I'm going to move my cursor all the way over here. Now, here's pretty close to the x-intercept. You just want to make sure you're on the left side of it. So click the left arrow a few times, even just once, so that way, like here's the x-intercept, we are somewhere to the left. Hit enter. The next command is right bound. So same idea, you go to the right. Now, with this one, you can go as far right as long as you don't pass another x-intercept. You pass another x-intercept, the calculator gets a little confused and shoots back an error at you. So you just go to the right, hit enter, guess. You don't have to actually do anything for that. You can just hit enter And look at that, our first x-intercept is at -8. But we can clearly see there are two more, so we have to do it again. So 0, go over here. Now, because I'm looking at this middle one, left bound, here's the 0. To the left of it, I am currently at, so I'd enter. Go to the right bound. Now I'm on the right side, hit enter. Something that actually is really nice though, before you hit enter with the guess, is they'll have these dotted lines here that if your zeros or whatever you're looking for is not in between those two, it's not going to tell you the correct answer, or might even not tell you an answer. So now when guess, we hit enter, and we get -3. So -8, -3, and the last one ends up left bound, right bound, guess, and we get 3 as well. So to answer this question, hide the calculator. To solve this, we just did, and we found that x could equal -8, -3, or 3. So there's our 3 answers. Okay, so that's to solve. Sometimes, especially with word problems, they might want the x-intercepts, which we just kind of went through how to find, but they could also ask for the minimums and maximums, local minimums and maximums. I can't talk. So in order to do that, we end up doing still the second trace, so it's all in this menu, which is really nice. And then depending on which one you want to look for, you either choose minimum or maximum. So let's go minimum this time. So the minimum is right there down here. I want the same commands as the x-intercepts, left bound, right bound, and guess. So left bound, I am to the left of this minimum value. Hit enter. Go to the right. Hit enter. And you can see, hey, we have the 2 lines. It's going to find whatever the lowest value is in between those 2 points. Hit enter. And you can see here the minimum value, the x value, is 0.513, but the actual minimum, the local minimum value is -74.37664. And that's only if they ask. Like I said, in word problems, a lot of times they will ask, like, what's the maximum capacity or what's the minimum capacity, any sort of thing like that. And we can easily find those with our calculator. Okay, and maximum's the same way. Now, I will say with these maximum and minimum commands is they will always work. So even if I do something like way over here, and I say, oh, that's my left bound, that's my right bound, even though I don't have a local minimum here, it will actually spit out the minimum value, which would have just been the left side of my interval. So you do want to make sure you're careful and that you go left of your minimum and the right of your minimum. With the 0, it usually does spit out an error if you mess up, but not with the minimum maximum. So yeah, that's using our calculator to solve polynomials and also finding their minimums and maximums in terms of their locals. So yeah, thanks for watching and have a good day.